Welcome to homework.
In this problem, we're given a set where A is equal to ABC, contains the elements A, B, and C. And we need to come up with an example of a relation R such that the symmetric closure of the reflexive closure of the transitive closure of R that is not transitive. So keep in mind, there are more than one possible answers to this question. So what I'm doing here is just one possible. You may do it and get a different answer and also be correct. So I will select a value R or the relation R. I'm going to set that equal to, so let R equal the element B, A, C, A. Okay. And the reason why I chose something of that form is because at the end, we know we do not want it to be transitive. So when we do the transitive closure, what we find is that it is equal to R itself. So here it is still the same. BA, CA. Okay. Now we are going to do the reflexive closure of our transitive closure. And what that means, based on what we know about being reflexive, then for each element of the set A, we should see A, B, B, and C, and so forth. So for the reflexive closure of this, then I would have to add the point AA, then I would have to also add BB, and I would also have to add CC. Okay, so this would be the reflexive closure of the transitive closure of R. Now we need to do the symmetric closure from the previous step. Okay, and based on the definition for symmetric, what that means is in the previous step, everywhere that I have, let's see, because I have BA, then that would mean I would also have to have AB. And here, because I have CA, that implies that I should also have AC. Okay. So our symmetric closure of the previous step would give us these following coordinates: AA, AB, AC, BA, BB, CA, and CC. So now that we've completed the symmetric closure of the reflexive closure of the transitive closure, let's test to see if this is transitive. So note here, we have the point BA and BC. Do we have an AC, sorry. Okay, so we have BA and AC, that should imply, based on our definition here, that should imply that we also have the point BC. Okay, and if we examine our last step, there is no point BC. So this would imply that this closure is not transitive. Okay? So the relation R that I started out with does satisfy the conditions set in the problem. So here we had BA, CA.